Okay. So we're going to use something called Gauss elimination, and then we're going to also use back substitution, which you would have seen in Algebra 1 or Algebra 2 where you put things back into the equation. And we're going to use this to solve our system. So we're going to write an augmented matrix. That was the matrix with all of the numbers here, and then you had dot, 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 and then you had more numbers over here, right? You had your constants, and you had your coefficients over here. And then we're going to use elementary row operations to rewrite that augmented matrix into row echelon form. So we want it to have 1, 0, 0, 1, 0, 1, and whatever comes after it. And then the numbers. And then we're going to write the system of linear equations and use back substitution. So x plus whatever equals whatever, y plus whatever equals whatever, and then z equals a number. And then we'll just plug that all back in to get x, y, and z. All right. So now this actually has 4 letters. It doesn't matter. It makes no difference here. But what we do want to switch it into is a matrix. So anywhere with nothing written at all, we're going to put a 0. And then anything that doesn't have a number on it, we're going to put a 1, just so we don't forget to pull those coefficients. Okay, let's make that augmented matrix. So we have 0, 1, 1, negative 2. Don't forget about the signs. And then that equals negative 3. 1, 2, negative 1, 0 equals 2. And then we have 2, 4, 1, negative 3, negative 2. And I didn't make this long enough. We have, 1, negative 4, negative 7, negative 1, and then negative 19. Okay, so we're going to use row operations to try to move this around. What might not be a bad idea to start with is picking one of the rows that already has a 1 in the first spot, because right now I don't have that. So whether you use the second row or the 4th row to move into the first position, doesn't matter. I'm just going to, I'm going to move this guy up. So we're going to switch those. Let's put 1, 2, negative 1, 0 up on top. And down below, under that, we can just move this over. And the beauty of doing this is it actually puts us in a really good position because the first 2 rows are already now good to go. Okay. All right, so all we did was take row 1 and row 2 and flip-flop them. So old row 1 went down here, old row 2 went here, and we just switched the position that they were in. Okay, great. So we are in good shape so far. Now what we need to do is try to turn the 2 and the 1 down here into zeros. Okay. So we're happy with the first and the second so far. So 1, 2, negative 1, 0. Let's rewrite those first and second lines. And it's really important to keep organized. A lot of people like to do this on graph paper because then you can just put a number inside each box and then leave a space in between. All right, so in order to turn this 2 into a 0, what I'm going to do is take row 1, let's multiply it by negative 2, and that'll make it a negative 2 that I can add, and it should cancel it out. So if I do that, let's see, row 1 times negative 2 is negative 2, plus 2 is 0, good. 2 times negative 2 is negative 4, plus 4 is actually also 0, that's convenient. Negative 1 times negative 2 is 2 plus 1, so 3. 0 times negative 2 is 0 plus negative 3 is still negative 3. And that's going to give us 2 times negative 2, so negative 4 plus negative 2, we get negative 6. Okay, so far so good. What we should also do is try to fix the bottom at the same time. So we want that 1 to disappear. Let's just subtract the top and the bottom row. So negative row 1 plus row 4, and that should take care of business. So let's see, that's negative 1 plus 1 is 0. Negative 2 plus negative 4 is negative 6. Positive 1 plus negative 7 is negative 6. 0 and negative 1. And then negative 2 and negative 19 is negative 21. Okay, so looking good so far. I actually noticed that I have... let's see, we can get rid of this negative 6. That's probably a good place to go next. So let's rewrite. We have 1, 2, negative 1, 0. We're happy with that top row. and the second row. So far, we're good with that row, the third row. We're going to have to do something to it eventually, but we're not there yet. All right, so that bottom row, let's fix that. Let's get rid of that -6. So to get rid of that -6, we could use a few different things, but let's do the second row. That way we don't introduce anything in this spot. So we'll do 6 times the second row, and we'll add that to the fourth row, and that should take care of it. All right, so that stays 0, right? 6 times 0 plus 0. 6 times 1 plus -6 is going to give us 0. 6 times 1 is 6, plus -6 is also 0. That's convenient. 6 times -2 is -12, plus -1 is -13. And let's see, -3. So 6 times -3 plus -21, that's -39. All right, so far so good. Now what we want to do is get rid of this 3. And if we can, let's get rid of this 13. And I actually see something I can divide out by. So let's try that. 1, 2, -1, 0. 0, 1, 1, -2, -3. And then let's do this. We can multiply by a third. That'll give me 0, 0, 1, -1, and -2. And then we can multiply by, let's see on that bottom row, how about -1/3 over 13? I think that'll do it. So let's see, that's 0, 0, 0. That gives us 1, and that's going to give us 3. Okay, perfect. All right, so we have that row echelon form that we're looking for. That's awesome. So now that we're in row echelon form, we can go and use a regular system now. So that first was X, the second was Y, the third was Z, and the fourth was W, but we don't have anything there. And then no X, but Y plus Z minus 2W equals -3. And then we have Z minus W equals -2, and we have W equals 3, which is awesome. Now we can use back substitution. So we're going to put that W back into this equation. So we're going to get Z minus 3 equals -2. That gives us that Z is equal to 1. All right, so far we've got W equals 3. We have Z equals 1. We're going to need what Y equals and what X equals. Plug in Z and W, and that's going to give us, let's see, Y plus Z is 1 minus 2 times 3 equals -3. That's going to give us Y, let's see, minus 5 is equal to -3, so we're going to get Y is equal to 2. And then lastly, we're going to plug in Y. All right, oops, so from here I just noticed my 2 here was positive, and then I accidentally switched it to make it negative, so let's go back. That was something I shouldn't have carried along. All right, so when we go to plug this in, we're going to have X plus 2 times 2 minus, what was the 1 equals 2. So that gives us X plus 3 equals 2. We're going to get X equals -1. So there is our answer to our system.